You know it's true. We'll just leave that there. Well, today I lay out a control box, find lots of stuff to put on there, and then more stuff, and then even more stuff still. Oh. Well, you remember this? Yeah, it's time to revisit and tear it apart and put it all back together with some new stuff. Okay, we're back at working on the 4x8 CNC machine, and we're looking at laying out the panel. So we've got our old lead shine controllers and power supply. Well, there's a stepper online one, and we're not going to use any of that. Instead, we've got these. These are closed loop hybrid steppers from Stepper Online. So the controllers are the CL86T, and the motors are 9 Newton meter NEMA 34 motors instead of the 42s that were on the machine. Let me grab one of those to compare. So on the left here we have the NEMA 42, and which is interesting about this is it's a 14 millimeter shaft, which all the documentation that I've read says that NEMA 42s have a 19 millimeter shaft. So I was really worried that by downsizing to the 34s, I'd have to get you know, shaft adapters and bore reducers for the gears, but they're the same size shaft, so I kind of lucked out there. But obviously the body size is different. This is 110 millimeter, and I believe this is 86 or something like that, or 88. Anyhow, yeah, that's the difference there. I'm going to have to, on where these mount to, I think all I really need to do is drill new holes and tap them for the Z and this Y, and over here the X already has the holes, they just need to be tapped, and then this Y. So that shouldn't be too hard. I don't need to worry about shaft adapters and bore size because they're the same. So these are 9 Newton meter. I have no idea what these are. Probably less. But these weigh a little bit more. So here's the motors. Here's the power supplies. These 4 are going to replace this one. Here's the old driver versus the new driver. Basically the same physical space. Now, what's the difference between this and this? In a nutshell, this, you're only sending it pulses to move one direction or the other, and the motor will move those pulses, and your controller or the system just assumes that it did. Now, what can happen if it misses a step, or say you're plunged too deep and it says to move over 3 inches, but it's so deep that you're missing steps and it only moved over 2.5 inches, or 2 7/8, whatever. The system isn't going to know that, and it's just going to continue to go, and then your parts are going to be the wrong size. Whereas this, so we have basically 4 wires going in, power, I believe pulse left and right or something like that. This, same 4 wires, but it also has an optical feedback. So this feedback says, okay, I need to go 10 pulses. And the optical feedback says, yep, you went 10 pulses, all is good. Continue about your way. And that's done between these 2 things. So you have your 4 wires that go into, I think here. And then your signal, your encoder, goes into here and it feeds back into this. And if it detects that there's a problem, it's going to send an alarm, it's going to stop. And there's different thresholds that you can set for the alarm. It's going to stop, and then you're going to get a message on your screen that, hey, something's wrong. The other thing that it can do, and I don't know the setup or the configuration of this yet, or how it works yet, I haven't dug into it too deep, is that it can compensate. And there's a couple different ways that it can compensate. One is it can just make up those missteps at the very end, or it can make them up as it's going. I don't know which this does yet. If any of that smart stuff, maybe it's not that smart and I'm assuming too much. Maybe it just throws an alarm, I don't know yet. So, but we will find out. So that's kind of that stuff. And I need to start laying out for real this control panel board. So let's start doing that. This is exactly the space we have to work with inside the control panel, which is this monster over here.
Across the forest floor, I've been walking for days and nights now, just back and forth, just back and forth.
We're close to getting this laid out. I am going to do what you see here.
I've been dreaming on pins and needles, looking for the signs. I've been dreaming for light years, baby. Turning my mind, turning my mind, turning my mind. Holding on to that ribbon, threaded through an eye. I'm living on pins and needles, one day at a time, one day at a time, one day at a time. I've been working on pins and needles, patching up the sky. I've been working for a month of Sundays, climbing so high, climbing so high, climbing so high. Holding on to that ribbon, threaded through an eye. I'm living on pins and needles, one day at a time, one day at a time, one day at a time.
What are you doing? What is this thing doing? Okay. Alright, so we've got our first bit of wiring going on. We have our power plugged in, going into this contactor, but before the contactor engages, we have a switch. So when I hit the switch, we should hear a click, and we should see 120 volts show up on the meter. I heard a click, and yeah, oh, 119.1, so that's good. Now, we need to make a bus bar to give power to all of these and this. Yep. Oh, was I not? So I just recorded nothing because I forgot to hit record. Anyhow, I just fired up these power supplies for the first time. You can see there's green lights on there, and I measured their voltage coming out. They are 56 volts each one. I don't know if that is where I want to leave it, or if I should bump it up to 60, because I think they are 60 volt power supplies. But if I go under, then it's under the rating and I'm not maxing everything out. It's kind of my thought process. These stepper drivers are rated for 24 to 80 volts DC, so we're well within their rating, so maybe I'll keep them at 60. I did have to balance a couple of these. These were like 55.2, so I brought them up to 56 even, so all four should be at 56 volts even. Now I'm going to turn the key, turn it off. We heard the contactor go off. Those little green lights should shut off. I'm sure there's capacitance in there holding some voltage, so they should blink off here shortly. They're getting dimmer. Yep, there they go. Alright, next up is to power up the Acorn. So this is going to just jump into here, and then I'm going to run power from one of these over there. So let me do that. So we're going on day 2 now. I kind of jumped ahead. I forgot to record this, but it wasn't really exciting. I wired the voltage out from the power supplies into the stepper drivers. And next is to wire up the signal out from the Acorn into the steppers. So we need pulse, direction, and enable, and the alarm. So that is already pre-designed for me. Luckily, they're on the Acorn website. They have the schematics for the CL86T, which are the, wow, my gimbal just like stopped, weird. But anyhow, the CL86T, here's the schematics for them, and yeah, we're gonna start wiring that. I'll put you back on time lapse so you don't have to hear me talk. What I did here, made these little jumpers. We've got the 5 volts coming from our terminal. Oh my goodness. 5 volts coming in, and so we basically need to do 5 volts here, 5 volts there, 5 volts there. So we just have these little jumpers, and that's that. I just need to make 3 more of them. I have the jumpers, I just need to wire them up. But first, it's lunch break. Well, she's got a pulse. We've got power to the Acorn. Lights are on. The little heartbeat is flashing. We've got Ethernet hooked up. We've got power on our power supplies. And we've got the software on. It's communicating to the board. So that is great. We're off to a good start. Next up is to get power to the drivers and then signal from the Acorn to the drivers. Plug in those steppers, set them on the bench, and start playing around with the software, make sure we can make everything work. But cool, so far so good. Plus, see what I've done. Got our power distribution block there, coming off this power supply, which supplies both 5 volts and 24 volts. 24 volts to the Acorn, 5 volts going here. That then runs to each of these here. We have our step and direction coming off of our parallel port junction box, our breakout board. And we have our enable signals coming out of here and going into each of those. So they are all wired as they should be according to the schematics. Oh, and I've made a mess of everything. Let's take a look at this. So here we see for the CL86Ts, because they only run off 5 volts signal, it's best to come off the parallel port. Here's the pin out for that. So that goes up to each of the stepper drivers, 5 volts DC. And if you look here, these junctions, 5 volts DC plus 5 volts DC and 5 volts DC for the enable, they're all the same supply. So that's what these little white jumpers are. And then we have enable 1, 2, 3, and of course I have a 4th axis, so we've got enable 4 in there. And yeah, that's it so far. I think I'm gonna hit I'm gonna wire up the e-stop next. That looks pretty simple. So we're coming off of common, goes through the e-stop, and it goes to input 8 there on the board. So I'm going to do that. Then I'm going to grab the steppers, temporarily wire them directly to here, turn everything on, hopefully not let any smoke out, see what it can do, see if it can make stuff move around. Right. Many hours later, we've got I skipped some stuff, so I've got, I don't know where I left off, but I've got the steppers wired up. I double checked the color codes in the stepper diagram and they were wrong, so I had to trace everything for both the signal and the stepper just to make sure it's all hooked up right. We have an e-stop wired up. That's here. Power switch. We have our alarm coming off the drivers here, so that basically just daisy chains the alarm plus and the common from one to the other. I think that's right. According to the diagram here, we have common sharing the same line, so that makes sense. And then the drive OK signal coming in over here and all dumping into input 5. So I think daisy chaining them should be just fine. We're going to turn this on and see what happens. What I'm going to do, turn on the computer, let that boot up, pick some stuff off the floor, get stepping on it, and I'm going to plug this in like so. That's wiggly. How did that get so loose? I need to tighten that up. Alright. Now we're going to turn this on. Watch for smoke. Alright. No smoke. We've got green lights on our power supplies. Green lights on our drivers. Don't see anything that would cause me to freak out. Okay. I'm gonna go CNC router. I should probably set that to automatically load. I smell wood. Oh, I think I'm out of pellets. Yep. That's alright. It's warm enough in here I can turn the heat off. Okay. Okay. Let's see if the e-stop release. Yep. Emergency stop released. Emergency stop detected. Oh. I've got, I'm going to switch these. So it's normally open instead of normally closed. That's easy. Alright, so for right now, we're good. That's about all I know how to do right now. So let me get this set up for whatever it's got to do, and we'll be back. A little bit of progress. Read a quick little tutorial setting up the Acorn for the appropriate drives. So far what I've learned is you go into Utility, Acorn Wizard, and that pulls up a thing that configures the Acorn. This is actually kind of cool. And the access drive type I set to Separ Online. They don't have the CL86T listed in here, so I picked a Y, and maybe that will work. I don't know. So I don't know if I can just exit out of here. Yep, I can. So then I wrote those settings, changed them, and saved them, and rebooted the Acorn, and now I can go. So this is Z, this is Y. I need to pair that with these two drives. Need to be paired to move simultaneously. So I need to figure that out. But cool, first test. Things are working. No smoke now. I guess if I unhook this, does that send an alarm? Is that working? Yeah, drive fault. Alright, cool. So we know we have our alarms. Gibble. Plug that back in. And that reset. That's clear. Let's see, are we on? Continuous. So that must be the fastest. Right now, it doesn't know about the fourth axis. Cool. All right. Well, I think that's going to wrap up this video. That was probably, I haven't edited it yet, and I'm going to try to cut it down, but I got hours and hours and hours of me sitting here plugging away at these damn wires, and I'm going to cut that down, so you don't have to see all this stupid stuff, but I'll make sure you see the cool stuff or the fun stuff. Anyhow, let's take one last look at the wiring here. Cool.
Kitty cat dance party. Kitty cat. Kitty cat. Cat.